Hi, this is Mr. Khan here, and for the next 10 minutes or so, various teachers from the math department will join me here to unveil the secrets to remembering some of the trigo identities and formulas, and we will also help you to recap how to solve trigo equations and inequalities. If you wish, you may make use of the table of contents at the side of the video to skip to any particular segment of the video. Trigonometry is a branch of mathematics that studies triangles and the relationships between the lengths of their sides and the angles between those sides. Now, the basis of what we're learning here is the right angle triangle. Now, you see one on the screen here. Now, the shape of this triangle is determined by its angles and its sides. Now, once the angles are known, the ratios of the sides are determined regardless of the overall size of the triangle. Now, these ratios are given by the following trigonometric functions. We have tangent, which is opposite over adjacent, cosine, which is adjacent over hypotenuse, and sine, which is opposite over hypotenuse. Now, one neat way to remember all this is to think of trois quarts so. How do we do that? Tangent, for example, TOA is opposite over adjacent. So all you need to do to remember tangent is opposite over adjacent is to think of trois. Same thing for cosine and sine. Okay? Now there is also the reciprocal functions of tangent, cosine, and secant given by cotangent, secant, and cosecant.
Hi, this is Mr. Xia, and I'm going to recap for you the graphs of trigo functions. This is the graph of the sine function, this is the graph of the cosine function, and this is the graph of the tangent function. It is important to know the graphs of these three functions by heart. One of the reasons for this is because it helps us to recall the trigo ratios of special angles, namely 0, pi over 2, pi, 3 pi over 2, and 2 pi. So, even if we do not have this table in front of us, we should know that sine pi over 2 is 1, and sine 3 pi over 2 is minus 1, cosine pi is minus 1, and the reasons why we can do this is because at the back of our minds, we have the graphs of the trigo functions. There are three other special angles, pi over 6, pi over 4, and pi over 3. In degrees, they will be 30 degrees, 45 degrees, and 60 degrees. We need to know the trigo ratios of these special angles as well. However, in this case, knowing the graphs of the trigo functions will not help. So how do we remember the trigo ratios of these angles? Sine pi over 6 is half, sine pi over 4 is square root 2 over 2, sine pi over 3 is square root 3 over 2. Notice that the denominators are all 2. Notice that the numerators go from square root 1 to square root 2 to square root 3. So that's how I remember the trigo ratio for sine. For cosine, we just need to flip the row for sine and we get the trigo ratios for cosine. Tangent is sine divided by cosine, so tangent pi over 6 will be sine pi over 6 divided by cosine pi over 6. In this case, tangent pi over 6 will be half divided by square root 3 over 2, that gives us 1 over square root 3. Tangent pi over 4, I get square root 2 over 2 divided by square root 2 over 2, and that gives us 1, and similarly for tangent pi over 3, that gives us square root 3. So to remember the trigo ratios for 30 degrees, 45 degrees, and 60 degrees, actually what I really do is I just remember them for the sine.